All right. Hope everybody's doing well. This is Jamie Ghost with Gresco Technology Solutions. I'm joined here by John Nunes. He's also with Gresco. And we're going to go ahead and start things now. Looks like we're about at half capacity. So as people join in, we'll just welcome them and try to answer all your questions as we go. So first off, again, thanks for joining us for this webinar. And wanted to let you know that we are going to be doing a Q&A at the end of this. So if you want your questions answered, please submit them to austin@raptormaps.com, and we'll try to get those questions answered at the end. So like I said, my name is Jamie Ghost, and company is Gresco Technology Solutions. And what we do at Gresco is we're an electric utility distributor. So what we do is we supply power companies with anything and everything they need, from transformers to power poles to solar panels, all the way down to hand tools, safety glasses, really anything that a power company needs to keep the lights on. That's what we carry. And recently, our most recent addition is drones, or unmanned aircraft systems. We got into this to help our company, help our customers to have the ability to get up and do their inspections, and everything else that we would use you use drones and electric utilities. Gresco's been around since 1960, so we're celebrating our 58th year here in 2018. What we cover, the customers, we cover a lot of areas. Of course, being in the electric utility business, we're actually owned by electric cooperatives in the Southeast. We sell to those companies, we sell to contractors, and then on the drone side of our business, we serve public safety, first responders, oil and gas, insurance, really just anything where drones are being used, which is a really wide variety. I'll let John Nunes jump in and introduce himself. He's more on our public safety side, but I'll let him tell a little bit about his background.
Good afternoon, everybody. It's still morning in Phoenix, by the way. My name is John Nunes. I am based out of Phoenix. Recently joined Gresco for the public safety sector. I come from a public safety background, also a fixed-wing pilot since 1974. I've been working closely with the FAA probably since 1980, and I'm an FAA Fast Team Safety Rep, and I cover the state of Arizona as a subject matter expert for UAS or drones. My specialty, other than teaching, Part 107, public use COAs, as well as the hands-on operation of these devices. I also specialize in wide area authorizations. I work closely with the customer and the FAA to make sure that these don't linger on for months at a time. Typically, with valid training and good reasoning behind it, I think our record has been 30 minutes to get a wide area authorization, but typically we like to have at least a 2-week lead time. Again, I'll be free to take any of your questions, and looking forward to this presentation. Thank you.
I also wanted to say that there's handouts. There's going to be 5 handouts on the right side of your screen. So if at any time you want to download this handouts, there's 3 from Gresco and 2 from Raptor Maps. Nikhil, if you want to go ahead and kind of tell us about yourself and tell us about your company, you can go ahead.
Yeah, absolutely. Thank you. So yeah, my name's Nikhil, everybody. I'm the CEO of Raptor Maps. Our company is one of the leading software solutions for asset management and drones, and we are the leading solution for solar in particular. So we were founded out of MIT in 2015. We're located in the Boston area. In the solar space, we actually have 2 gigawatts under management right now, which is about 75,000 football fields worth of solar, and that's continuing to grow every day. What makes Raptor Maps special is we have a combination of asset management, so not just the inspection on what you can actually pull out of the drone images, but what you actually do with that and how that integrates into the workflows that companies are currently using for asset management. We use machine learning, which is being able to automate the detection of certain types of conditions that our customers are looking for. And one of our major specialties is actually thermal image analysis. So if you kind of put all those things together, solar is an extremely logical fit for what Raptor Maps does. Our customers are typically owner-operators of photovoltaic systems or solar farms, or sometimes their service providers, whether that's service providers in terms of the operations and maintenance companies, or service providers as in drone service providers that are servicing them. And so our software helps them get it all analyzed, make decisions on how to cost effectively deploy resources, and allows our customers to really manage their assets from everything all the way down to, you know, the nitty gritty, all the way up to the portfolio level.
All right, I'm going to cover the agenda that we're going to be going over, and then we'll just dive right in. And feel free, guys, John, Nikhil, if you want to jump in and cut me off at any point in time, please do so. Be glad to have your expertise on answering these questions and giving the most value. So the 7 kind of areas that we're going to be covering is the value of UAS for renewable energy and utility teams. What are the types of UAS or drone models, cameras, and accessories we recommend for the job? When and how we recommend using drones, and the easiest and fastest way to turn your inspection data into usable information. And then we're going to finish with a live Q&A for all attendees. So like I said, make sure you submit any questions to austin@raptormaps.com, and then we'll get them queued up for the end of the call, and we'll make sure we answer your questions as best we can. So I'll start off with number 1, the value of UAS for renewable energy and utility teams. So really, the low-hanging fruit is what we like to call it in the drone space, is for vertical and aerial asset inspections. So really what that means is you take a sensor, whether it be a thermal imaging camera or a visible light camera or any number of sensors, and you put it on a really stable and a gimbal mounted system, and you get up high and you take pictures, you take video of your assets, whether that be solar panels or electric utility, transmission lines, distribution lines, really anything you're wanting to get up high and see. Really, in the past, we've been handicapped with only the ability to put manned aircraft in the sky to see down on certain angles, certain views, and then gathering data through something like 75,000 football fields would take years of walking through and trying to gather those photos and then figure out how to actually use them. Some of the UAS, some of the drones, the models, cameras, and the accessory types that we're using, that we're recommending for people to use. Let's see. Are honestly, the Inspire 1 is has been the workhorse in our industry, and the reason that is because it has a great price point and also has the ability to swap out payloads, so you can quickly interchange a thermal camera with a visible light camera. And this has been years. It is an older platform, so it lacks some of the newer features that everybody's come to know and love on the newer platforms, such as obstacle avoidance, the ability to payloads, water resistance, and then the flight time is not great. The Inspire 1's around 20 minutes. The other platform that's really is taking the place of the Inspire 1, and I think it'll completely replace it over the next year or two, is the Matrice 200 series. The Matrice 200 has the ability to put a thermal camera on and a visible light camera at the same time. And actually the XT2 is kind of what we're recommending for people to use, because it's a dual camera. It has the FLIR XT technology. It's built by DJI, so it meshes seamlessly with the Matrice 200 series. Then again, it has the ability to fly it in rain. So if you get out and you're doing an inspection, it does start raining, then you can get it without damaging any of the parts. Then you can use the open SDK on the Matrice to plug in any other payloads that you would use. So when and how we recommend using UAS. So with our customer base being an electric utility base, there's lots of assets, lots of expensive equipment that's out there that you need to constantly maintain, and getting a UAS, a drone out there to do the inspection, being able to get the video and the pictures that you're needing to get, certain angles that we've all been trying to capture for a long time. Now this gives us the ability to do that. Austin, if you can put up the slide that has the picture, the image of the.
Yeah, you can. They'll actually be able to download that on the handout.
Okay, good deal. So as you can see, some of the things that we recommend using in your everyday use, what we did, because we're an industrial distributor, we try to combine all of the hardware and the software together to make it kind of seamless, to where you can just get out and you get your hardware, get your software, and you get out and you can fly your missions. This is actually how we met Raptor Maps and realized the value that they bring to the table. Met them around a year ago, and what they bring to the table is we all know that when you get out and you take pictures, you might take several thousand pictures out over weeks and months and years of taking these pictures, and honestly, to process that data would be just about impossible if you were to sit down and just have a human go through it. So they use the machine learning to go through and quickly process and pick out the flaws. I'm going to pass this over to Nikhil and let him help me with the how we recommend actually using your UAS in the PV solar inspections.
Yeah, absolutely. So yeah, we want to dive in a little bit and talk about solar in particular and what we're seeing across the industry. So Jamie mentioned the low-hanging fruit, and really the absolute slam dunk today that everyone is moving towards is do an inspection on energized assets. So what I mean by energized, these are solar farms that are in operation, and the most common thing to do is for the companies that are doing the maintenance or who own and operate the solar farms to fly their drone with a radiometric thermal camera to be able to capture data on which modules are performing well, which ones aren't, major site issues, things like that. And then they're also using it to take color imagery as well, so you can correlate the two, and you can see things like are the modules, module aka solar panel, are they shattered or are they soiled, things that can significantly affect the performance. Now the reason this is so important is that companies are realizing that it's just saving them a ton of time. So it used to be that in solar, what you would do is you would go through and you do manual electrical testing and a physical site walk down. And the asset owners who kind of have mandated that in the contracts, they're starting to see that not only is aerial thermography with drones much better, but it's much more comprehensive. Instead of getting a report, a detailed report on maybe 20% of their solar farm every year, they're getting the whole thing at once. And on the maintenance side, it's a lot better because instead of opening up, combiner boxes that are live, where sometimes you actually need to have two people, now they're able to easily, go out in the field with a single person in a matter of minutes and cover a significant amount of area. So that's why, companies are using drones for inspections. Pulling back a little bit, drones are also really, and this is a big part of where the software comes in, being able to query what's going on the both on the site level within the site, compare different sections to each other, but also being able to compare different sites across your portfolio. So, that's very standardized, and companies are able to do lots and lots and lots of sites that are under management and then compare them and figure out, okay, here's where I need to deploy assets in order to most efficiently maintain my solar installations. So one of the things people don't think about is the fact that, you may not have all the materials you need, for example, and some of that may have a long lead time. So if you know you need it or you're going to need it very soon, it's much better to order that and not waste anyone's time until that thing has arrived exactly where it needs to be. So there's a lot of optimization that can occur at the portfolio level. Now pulling back a little bit, so that's once the systems are energized. Now you're starting to see a lot of use of drones during the construction phase, so construction analytics. And the reason that's so important is that the way the industry works is a lot of times there are incentives to hit a certain build deadline, tax credits and things like that. And so these companies absolutely need to make sure that they're on schedule. These are very, very tight build schedules. So being able to graph out, how many modules have I added this week? How much racking have I added this week? Things like that is something that drones are helping a lot with, because the, really quick, weekly drone scan is giving them a lot of information. And then finally, the third way drones are helping in solar is, site selection. So looking at different sites, figuring out, okay, is this a good place to build a solar farm? Is there a grade here? Is it going to flood? All of that different, topographical considerations, shading considerations. So you can kind of see how it's really useful across the life cycle. And we'll talk about a little bit later, maybe in the Q&A on the different parties that it's useful to. One other thing I should mention is the transition from construction to fully energized system is called the commissioning. And so typically it's almost a requirement nowadays that you do a drone inspection at commissioning to pick up on major issues. And this is really good from the standpoint of the people who build, because they can pick up on the issues before they turn the site over. And it's really good due diligence on the side of the people who are taking ownership of that asset.
So Nikhil, this is Jamie. So what you're saying on the construction side is that teams are going out and flying maybe once a week or twice a week just to keep track of progress. That's one of the large things, use cases they're using these for.
Yeah, because remember, these are all, these sites are all, bankrolled. They're financial backers that are looking to make sure that they're built on time and that they're going to get get all of the incentives, for the solar farm, and that everything is built according to their cost model. So they need to be very, very tight about how things are getting built and keep a really close eye on it. So yeah, people are using drones now during what we call the dynamic phase of construction, where they're actually, they've broken ground and they're adding assets day after day to build up that solar farm.
Okay, great. So they're doing construction, they're using the commissioning, and then teams are using these to manage the solar farms. Can you talk a little bit about how they're doing that?
Yeah, absolutely. So how that works on the management side is that we're seeing, companies will generally send, they'll have a few people that are Part 107 qualified if it's within their service radius. Sometimes they'll be managing an asset that's a little bit further away that they may choose to, contract out a service provider. And so they'll have, they'll budget for that person to, spend just a little bit of time on that site, one or 2 hours, and do a drone scan and see, just get a baseline of what's going on and be able to address any major issues quickly and then move on to the next site. So instead of, a technician going out and spending all day or multiple days on a single site, what they're doing is using the drones to qualify everything that's going on a particular asset, and then strategically deploying their technicians. Because you got to remember that these technicians are pretty highly skilled people, right? Their time is not best spent doing kind of, mundane electrical testing or just walking up and down. Their time is best spent actually fixing these assets. And one of the things people don't realize is that besides just the labor savings, drones are giving companies that build and maintain solar assets the ability to cover a lot more territory with the same workforce. And so, as this industry is growing like crazy, for those of you who may not be familiar with it, every year the metric is, have we added at least as much solar as the previous year? Or, how do we stack up compared to that? And so for all of that solar that's being built, you still have all of that solar that has been built in the past that you still got to take care of. So that's why it's growing exponentially. And so, companies are pretty strained in terms of being able to take care of more and more and more assets without significantly increasing their costs. And drones have alleviated that bottleneck.
Awesome, great. So we've kind of covered some of the use cases and kind of at a high level. So talk through and tell us about some of the common mistakes that you see companies using as they're adopting UAS for solar inspection.
Yeah, I think the most common mistake is, they'll go and they'll see a demo, and they'll, if you see even one thermal image of some condition on a solar farm taken with a drone, that is really exciting. That's exciting when we see that. It's certainly exciting to the people who look at it. And so, that's kind of where the thought process sometimes ends, and they say, great, let me get this piece of equipment. But then they don't put as much thought into, how do I build up a good, robust system around it? So how do I make sure that if I've got a distributed portfolio of 100 1 megawatt rooftop sites or community sites, or if I'm going to go do utility scale sites, which are dozens to hundreds of megawatts, how do I actually have a system in place to manage that data, to compare the results from between one scan and the other, to compare the results between different sites? And they just don't realize how extremely labor intensive it is to actually classify and localize what's going on a solar farm. And so they think they're going to save a ton of time, but then they shift the burden from technicians out in the field to technicians sitting back at the office trying to put together a jigsaw puzzle of hundreds to thousands of both thermal and color images, and try to match that up with the as-built construction drawings that may have millions of modules. We've done sites with over 4 million modules, and that's a real challenge. And so that's a mistake that a lot of companies make. Fortunately, that one's pretty correctable. They'll generally find their way to us, and we're able to get them set up pretty well. The other mistake people make is just it just comes down to having good data quality. We put out a lot of guidance, and you just got to read it and make sure that you're verifying your data when you're out in the field, because you don't want to be going out and doing this twice. And so everyone who's on the webinar right now, it is one of the handouts is literally our guidelines. So if you print that out, throw that in your Go Professional case, or put it in your flight binder, that'll save you a lot of headache when you actually want to get really good results out of your flights.
All right, great. Thanks for that. So we're going to move from the hardware and really what you do when you get out and fly to really the hardest part of all this. The part that the Raptor Maps really kind of helps everybody out with is processing the data. And we've been to so many drone shows and trade shows, and really there's lots of cool hardware, lots of cool software out there, but the problem always comes back around to data processing. So I'd like to dig into that. How do you process all the information that you get? How does Raptor Maps enable teams to turn drone data into actionable reports? And so I'll start off with this. So what are people doing with the data today?
Yeah, so right now you've got everyone in the camp, from people who are just trying to look at pictures and try to give their asset owners pictures of what's going on, all the way to people with several gigawatt portfolios that have a robust system in place using Raptor Maps to actually incorporate that into some of their other workflows, some of their other software, and use it for asset management. So you got everything in between. You've got some people that are just using the thermal camera and giving that and taking video, and their technicians kind of just fly around and use it as an eye in the sky. You've got others that have realized that it's for about the same amount of time in the field, you could be taking, a really good, robust data set that's going to allow you to benchmark that site and compare it against itself for the next time. So I'd say it's all over the place, and that's why a big part of what we do is, a lot of the education component, just to help people understand how to use their time effectively and collect data that's going to serve them well beyond just, a single inspection.
All right. So some people are using it as, like you said, the eye in the sky, like video feed. They're getting a thermal camera up there and they're seeing hot spots or light spots on a panel, and they can pick out the bad cells by doing that. Other people are downloading the pictures and post-processing the data using a number of ways. How are people managing the review of the data? How are they making reports? Who's doing that inside their companies? What does that look like?
Yeah, so typically, if it's a solar company that's doing operations and maintenance, it's their own technicians that are doing that, which is a big part of the reason why they really want to use software. So software is really good for two things. One is the actual analysis, but the other equally important part is the reporting and workflow integration. And so, they realize that, man, after all of this analysis, and because for some of the sites, we've done sites that'll have, over 2,000 defects, some even more than that. And so, you got to imagine that, A, that the eye in the sky approach certainly doesn't work for that. And B, let's say next time you've got, more defects or fewer defects, or you've addressed things, like how are you going to actually compare that? So yeah, what we do is we kind of take the analysis burden off their plates, but we also do the workflow part of it as well. And so, yeah, I think, what companies have realized is, they'll go out and they'll be able to do a small site and get really jazzed about it. But then they realize, well, if I actually want to do the analysis in-house, I have to hire more people, and that defeats the purpose of using drones in the first place.
Yep. Cool. Well, the next question is something that we've at Gresco we've been asked. Like I said, we're a supplier, we're a distributor. So what we do really well is learn a lot about the products, figure out exactly what companies need, what they need to be out in the field. So that's why we put the utility packages together. What we're not experts at is actually getting out and flying, because most of the time what we do is we fly demos to show off the equipment, to show their uses. We do have engineering staff that they're super technical and can tell you everything there is to know about the products. But one of the problems that we've run into with customers is photogrammetry and actually making thermal maps. And so this is the next question I want to ask you is how do you do that? Is that the most viable way to go about making to review your data, or do you recommend something else?
Yeah, we definitely recommend something else. So it's pretty interesting because when we, as Raptor Maps started getting more into the thermal space, we were pioneers of making radiometric orthomosaics. But for solar, that's not the best deliverable by far, and there are a lot of reasons for that. One is, but at the altitude where you're actually getting meaningful ground sample distance, your map's just really not going to come out. And a mapping mission requires a lot more side lap, which adds quite a bit to the flight time. And so what we've focused really hard on, and the reason we put so much flight guidance out, is to be able to spend the least amount of time in the field. And the way we're able to let our customers spend the least amount of time in the field is by doing the analytics on an image by image basis, as opposed to trying to put together a map and then creating a digital twin of their PV asset to actually map those defects onto. So that's what we do. So taking a step back, the input that comes, just to be really clear, what our customers hand us. They'll hand us a data set, a thermal data set that covers the installation. They'll typically hand us a color data set as well. And then we'll have some sort of site plans, typically that talk about how it's wired up and how many modules per string and that kind of thing. And between those three things, we're able to make in addition to listing off the defects, localizing them, all of that stuff. And we'll get to what those deliverables are. Yeah, we're able to make a defect map, but it's not a map in the traditional sense where people think of a radiometric orthomosaic. It's more useful.
Okay, great. Yeah, that's the problem. One of the problems we've had doing that or trying to do that is exactly what you're saying. That's the reason why.
Yeah. Well, it also comes down to consistency. If you manage lots and lots of sites or major sites, you need to be able to guarantee that the results are going to come out. And we haven't been able to see that kind of consistency when it comes to, radiometric orthomosaics.
All right. Real quick, I know we're pushing our time just a little bit, so I'm going to give you a couple questions. Can you tell us what's different about Raptor Maps than other software solutions that are out there, and then what does your workflow look like? I know you kind of covered workflow in your last answer, but can you just tell us how you're different and then what your workflow looks like?
Yeah, absolutely. So we're very focused on solar deliverables and machine learning and actually making it actionable. So this is a little bit different than your software out there there's great software out there that's geared towards, mapping and cut fill analysis and a lot of the more, construction site and mining and quarrying applications. So sometimes when people don't quite understand what Raptor Maps does, they may be a little confused and try to put it in that bucket. What we do is much more along the lines of asset management. So we'll take in data, it's particularly geared for solar thermal data, and our outputs are particularly geared for the solar industry. So, it's a very tailored product, and that's a big part of what makes it different. And yeah, in terms of workflow, our customers will upload the data that we typically flown according to our specs or recommendations, and then Raptor Maps will process it. So that data consists of thermal images, color images, and site plans. Site plans aren't always necessary, but they're very helpful. Site plans, as-built drawings, construction drawings, all synonyms, more or less the way I'm referring to them. And on the what Raptor Maps produces is a lot of different deliverables, because some clients have incorporate them in different ways. So we'll produce a PDF report that they can either hand to their technicians, or they can hand it to their asset owners to say, hey, here's what I'm working on. And I think we made that's one of the handouts is a sample PDF report. Another thing we provide is a KML file. This is typically for our customers that are using like GIS software, whether it's something like ArcGIS or whether it's something free like Google Earth. We'll provide a spreadsheet in case they want to be able to filter that or read it into a different piece of software. That'll literally tell a technician, okay, go this many rows up, this many strings over, this many modules up, and this is the exact module, or the exact is exactly where you need to go. So no GPS necessary there. And then we'll also provide an online interface, because people want to be able to see the data, spin the virtual world, add in their comments, manage it on an organizational level. And so we provide every site becomes a report for our clients in there as well. So, I think it's a little bit overkill, but the reason it is because different clients use the data in different ways. And we just have a standard process to make sure that no matter who it is, they're getting a lot of value out of it. So those are the outputs.
All right. Well, great. I think I know that was a high level, so I hope everybody pulled a lot of information out of there. I just wanted to say thanks, Nikhil, for going over that. I hope that helped out. I know I'm really excited about what Raptor Maps is doing and our partnership. Another area I wanted to go over real quick, and I'm going to let John, who he described himself earlier, and he really is an expert on everything involved with airspace, and he does training. And I wanted him to cover something that people have issues with data management, but another fear that people have is on regulation. So before we get into the question and answer session, John, if you want to get on here and just talk kind of where we're at today in with the regulations. We're where we started at in 2016, and if you can take 2 or 3 minutes to just really quick wrap up where we're at and how people can kind of get set up or set themselves up in their companies to be able to actually use drones, legally.
Certainly. So up until 2016, the FAA literally allows you to pilots to fly under Section 333. So you go through a lengthy process to get your 333 authorization. The stipulation was you needed to get a pilot who was current with a biennial flight review, had a valid health certificate or a medical, and it got quite cumbersome, quite complicated. Oftentimes people were just going out and flying and hoping that they wouldn't get caught, and those that did paid significantly for it. Then with the advent of 107, things got much easier, yet we as an industry typically, what I see a lot is, ask for forgiveness. And if you get caught, those days are coming to a slow now because the FAA is starting to go out there and clamp down on people. Granted, a lot of the solar farms that we see are out in remote areas, typically not in any Class Charlie, Delta, or Bravo airspace. Here in Tempe, we've got quite a few at ASU, and they're in the middle of Class Bravo airspace. So for those that are in restricted area, and oftentimes we find them as part of critical infrastructures, make sure the regulations, make sure you've got the proper documentation, because you may be able to get away with it, but once the regulatory people have you on their crosshairs, your life will be miserable. So I urge you to figure out what airspace you're going to be in, get the proper authorization. Most local FAA FSDOS flight standards district offices will work closely with you or point you to the right people to do it with. And if you get stuck, feel free to call out to us, and we'll guide you down the right path. But nothing worse than falling behind the crosshairs of the FAA or DHS because you may have been in a critical infrastructure facility. That's all I've got, and I'll take any questions as they come up.
All right, thanks, John. So Austin and Akil been keeping track of all the questions and creating a list for us to go through. And just want to let everybody know that we're gonna answer the questions we can here in the next 15 or 20 minutes. And then we will answer all of the questions over email. So if you want to send any questions that are not answered to info@raptormaps.com, we'll make sure that we get back to you as soon as we can after the webinar. So Nikhil, if you want to take it away and read off some of the questions that we have, we'll do our best to answer them.
Yeah, absolutely. So Christopher asks, how long did it take Raptor Maps to develop the solution? And the answer to that is that we actually started developing it several years ago when we were building out a drone data management platform to do machine learning. So that part of it was built out over time, and kind of one of the big inflection points for us was, adding in the ability to do thermal image processing, and then moving into making radiometric orthomosaics for customers. That kind of made our platform very attractive for people who were doing PV system analysis or solar farm analysis. And the reason for that is, asset owners were actually starting to mandate that they wanted it, that they were replacing certain provisions in their contract with using drones. And so we had a lot of customers coming to us saying, hey, Raptor Maps, we know you guys do, drone data management for thermal. This is what we're trying to do in solar. And so it wasn't exactly what our product did at the time. And so we've taken the time to actually build that out. So yeah, I would say over the past couple of years, to answer your question. All right. Derek asks, and keep the questions coming, guys. We're happy to answer them. So Derek's asking about, does Raptor Maps have a built-in function for 3D modeling, BIM, and level of development for construction sites? So typically for solar, we'll work with our client to identify what they actually want to see on their reports. these sites are built very quickly. So, typically once they break ground on it, they're putting in the support structures, they're putting in the racking, they're putting in the modules, and then so there's I think it's called physical completion, and then there's full completion. And full completion has more to do with, have you energized the site and have you hooked it up to the grid. So, yep. So to answer your question there, we do that on a customer by customer basis, depending on the analysis that they want. All right. Mark asks, have you guys tried the Workswell Wirus, or I've heard some people pronounce it Wirus? Yeah, I think I'll let Jamie take this one. Have you guys do you guys distribute for that, or have you had customers that have worked with that?
Can you say that again?
Yeah, so the question was, have you tried the Workswell Wirus or Wirus? It's a thermal camera.
No, we're not distributors. I've seen those guys at some trade shows, but I'm not familiar.
Yeah, so for Raptor Maps, we've processed data from a lot of different camera platforms beyond just your DJI Zenmuse. And so if it's a radiometric image and we have the appropriate metadata, we can process it. That being said, for turnaround time and for consistency, we've found the DJI platform to be, incredibly consistent. Our customers that are flying them, we never have any issues with, oh, this metadata dropped off, or, I didn't have the gimbal angle or anything like that. So that's just something to keep in mind. So, we're hardware agnostic, but at the same time, we've just seen a lot of success with customers flying with DJI platforms.
Yeah, same here. And one of the reasons that we actually carry, because typically we're the exact same way. We pick out the best products that we could find. Like I said earlier, we carry transformers and poles and wire. We want to carry the highest quality for the best price products that we can possibly find. And DJI, we can't find anybody that makes a better product. We also do carry a fixed wing vertical takeoff and landing from bird's eye view, and that's called the Firefly 6, and we've been really, really happy with them. They're made out of New Hampshire, and we work with those guys really closely. So yeah, DJI just seems to work seamlessly with what they have. They do have the Open SDK now, so you could potentially integrate non-DJI sensors into the Matrice 200 series, and it fits right in with the gimbal. But up to this point, yeah, same here. We've really stuck closely with the Zenmuse XT by FLIR and DJI. So yeah, thanks for taking that.
All right, and Christopher asks, do you know the success rate to identify a defect? I'm assuming there's still a human validation. And Christopher, you brought up a really, really good point. At the end of the day, customers need this to be highly accurate and actionable, and so if you were to get a machine learning result and immediately just hand it to them without any human validation, that would not be a responsible thing to do. So yeah, there's definitely a human validation component. In terms of the success rate for defect identification, that really is good data in. The success rate's extremely high. If the data quality coming in is not very good, then it's not going to be as successful, and then that's going to take a higher human component to actually go through and QA that. And the carrot for our customers is that affects turnaround time, right? So if they fly it well, they fly it according to our guidelines, they can get results very quickly. If they fly it really poorly, where there's a ton of noise, the irradiance isn't very high, they got a ton of glare, all of these factors that can, foul the imagery, then there's a higher human validation component that's needed. All right. Derek says, thank you for the response. You are welcome, and anyone else is certainly invited to to put in a question. David asks, is the XT2 recommended to capture RGB imagery also, or is the 12 megapixel resolution not the best? So yeah, I'll let Jamie respond to that camera question, and then I'll chime in just on our general guidelines for RGB.
All right, could you read that one more time?
Yep. So is the XT2 recommended to capture the RGB imagery, or is the 12 megapixel resolution on it not the best?
Yeah, absolutely. It is the 12 megapixel is from what we've seen is plenty resolution for to capture the we need to. Then it has actually on the XT side, on the thermal side, it has the same resolution as the other the former, the XT1. So yeah, absolutely, you can get out there with the XT2 and use that on the RGB side. And I think Nikhil has actually probably with what they recommend for resolution and how many pixels you need to get on each picture, how high you need to fly. That's a little bit probably more important than actually having a different camera than that.
Yeah, and from our standpoint, we process the way our software works is we'll process and localize, on the thermal. We'll do that on the RGB, and then those are cross-referenced. And so, yeah, it doesn't necessarily matter to us if they're directly integrated or they're a little bit separate. At the end of the day, it's an optimization for our customers based on, is it more convenient to use the XT2 and fly it once, or do they really like some of the other camera platforms? And the reason we're not too concerned about it, I think the XT2 is really cool, but we're not super concerned just because the RGB camera, the footprint of that is so large that if you do need to add a second flight on to capture it, it's really not the end of the world. It doesn't add a ton of time. So yeah, excited about the XT2. Certainly not a requirement. All right. Tim asks, have you had any public safety agencies use Raptor Maps? Yeah. So the answer is yes. We've actually, if you look on our blog, we did a case study with a drone service provider up in British Columbia who was authorized to fly wildfires, and we actually took a machine learning approach to that to be able to automatically detect the hot spots and where they needed to go in order to stamp them out and let people come back into the evacuation zone. Where Raptor Maps is really good is when you have a defined problem and a way of solving that with machine learning, particularly in thermal. So that's why that's a good application. But solar, is a perfect application for that. So, for public safety agencies where Raptor Maps wouldn't be the best fit is, if I'm trying to, fly and look for something, look for the one needle in the haystack, and I'm trying to do that in real time, and I don't have a lot of other examples of that, that may not be the best fit. But if it's, I'm trying to, just for example, pick out a bunch of, orange life jackets in a sea of blue or something like that, that's where we're really good at that kind of thing. So, good question, Tim. Christopher, is Raptor processing videos input? That is a great question. The answer is yes. We will work with customers that have larger portfolios that may need to do that for one reason or another, and we do have customers that do that. But we highly, highly recommend taking the radiometric JPEGs instead. And we found that it actually is the same amount of time in the field, and the data quality tends to be better. So yes, we process videos input, but do not recommend it. Good question, though. Are there any more questions? We've got about 5 minutes left. All right. Well, that's exciting. Normally, we've got a ton of questions we don't get to answer. In this case, I think the Gresco and Raptor Maps team did a pretty good job. I also do want to thank Austin. You guys probably didn't hear him here today, but if you've ever called Raptor Maps, you will speak with him on the phone. So he's definitely a really good point of contact for any questions that you guys may have. Oh, we did get another one. Oh, Justin, best way to approach solar farms. Oh, that was a softball question. Yeah. So, yeah, one is we have the handout. That's a really good checklist. We also, if you go on our blog, you'll see links to there's a Solar Pro article that we wrote to Industry Trade Magazine, so you can access that. We've done webinars with FLIR, for example, that get into, show some pictures and kind of get into the nitty gritty of how to fly, how to set up your flight patterns. Oh, you actually did remind me of a question that Jamie asked earlier, which is what's a common mistake people make. One common mistake people make is trying to fly manually and not using any sort of flight planning. So you can set up your flight plan in Pix4D, Drone Deploy, Ground Station Pro, any of those. You can set the side lap and overlap pretty low. You don't have to use them only for mapping. You can use them for flight planning. They're free to do that, and so we highly recommend you do that because it makes the results very consistent. Justin asks, all right, it's another question. Drone Deploy. Yes, Drone Deploy. So you can do your flight planning in Drone Deploy. So you can set the overlap and side lap. One of the things you want to keep an eye out for is being able to set the gimbal. So the reason we have you guys fly a certain way, and typically that's it's sideways if it's a multicopter, is so you can match the PV panel angle with the gimbal and avoid glare. So as long as you can do that in your flight, in your ground station, any ground station is gonna work for you. So we see GS Pro is pretty common. Some people are more familiar with Drone Deploy because they like to use it for like construction mapping, so that tends to work okay. Pix4D. Some people get a little crazy and use Lychee. Yeah, as long as you're flying according to the specs, it doesn't matter too much. All right, so I think that's all we've got time for today. We really appreciate the great questions. Yeah, on the last slide, you'll see our contact info here. If you want more information on Raptor Maps, definitely shoot an email to info@raptormaps.com. On the Gresco side of it, really want to thank them both. Shoot an email to uas@gresco.com, and they'll be able to answer any questions. And yeah, do you guys have any closing thoughts?
Just one on our end. Actually, on May 15th and 16th, we will be at the Solar Power, the Southeast Solar Power event at the Sheraton Hotel in Atlanta. So I'm sure there's a lot of solar-specific users on here that are listening. So I know this information will be irrelevant on the recording in a couple weeks. But for everybody who's listening right now, me, Jamie Ghost, Gresco, and Austin Coffin with Raptor Maps will be in Atlanta at the Southeast Solar Power Show. And that is it. That's all I got.
All right, thank you, everyone. Have a fantastic afternoon, or I guess rest of your morning if you're still on the West Coast. And yeah, don't hesitate to reach out.